Just like with other sequences, we can find the partial sums of an arithmetic sequence, but because arithmetic sequences fit a special form, their partial sums will have a special formula. Let's take a look at an example of an arithmetic sequence and see what's happening. Let's consider the sequence 2, 12, 22, 32, 42, 52, 62, 72, and so on. Let's say that we want to take the partial sum of the terms that we have so far. 2 plus 12 plus 22 plus 32 plus 42 plus 52 plus 62 plus 72. Now, we could go and use a calculator and just do that, but I want to do this in a very particular way. I want to add the terms in pairs, starting from the beginning and the end and working our way inward. So I want to look at 2 plus 72. I want to look at 12 plus 62. I want to look at 22 plus 52. And I want to look at 32 plus 42. Each of these pairs on their own. So 2 plus 72 gives us 74. And then 12 plus 62 also gives us 74. And then 22 plus 52 also gives us 74. And then 32 plus 42, you guessed it, also gives us 74. So in each of these pairs of numbers, we got the same sum, but I'm less interested in the sum actually as the average of each pair. Remember, to find the average of two numbers, you add them up and divide by 2. And so if we wanted the average of each of these, we'd have 2 plus 72 over 2. We'd have 12 plus 62 over 2. We'd have 22 plus 52 over 2. And we'd have 32 plus 42 over 2. And in each of these situations, they have the same average of 37. And this is something that ends up being true whenever we're looking at an arithmetic sequence and we've got a partial sum. If we look at the partial sum and we add the terms from the beginning side to the end side in pairs, each of these pairs will have the same average. And this is very useful because this will help us add up all of the terms. If we look at each of these pairs and they have the same average, it actually turns out that all of the numbers, when taken as a group, have the same average. And so what we can do is we can take that average and multiply it by the total number of terms, and that gives us our partial sum. And that actually is going to give us a formula. For an arithmetic sequence, the nth partial sum, S sub n, is given by the formula S sub n equals n times a plus a sub n over 2, which just means the first element plus the last element divided by 2, or the average. So to find the nth partial sum, we take the number of terms times the average of the first and last term. This is a perfectly good formula, but we do have another one because we know that the nth term is given by the first term plus n minus 1 times the common difference. We can rewrite this formula in terms of the first term and the common difference instead of the first term and the last term. I know that might seem like a lot, but let's use that to figure out the partial sum here instead of going through and adding all of these together. So for our example, we've got S sub n equals n times a plus a sub n over 2. So in this particular example, we're taking the 8th partial sum because we have 8 numbers. So we've got 8 times 2 plus 72 all over 2. Well, we've actually already figured out the average of 2 and 72. It's 37. We've done this math. So we've got 8 times 37, and that is equal to 296. So we can use this formula to figure out what that partial sum is without having to go through the trouble of color coding things and adding up all of the numbers. And this is particularly useful if we're looking at significantly more than 8 terms. If we're looking at 100 terms, we don't want to have to go up and add 100 numbers together. It's much easier to just plug things into this formula. Let's take a look at another example. Let's find the sum of the first 40 terms of the arithmetic sequence (3, 7, 11, 15, etc.). So here we want to find a partial sum with 40 terms. So we're looking for S sub n here. And we actually have two formulas we could use. If we look back up here, we've got n times a plus a sub n over 2. And then we also have this other formula in terms of n, a, and d. Now, we don't actually know what a sub 40 is for our sequence here, right? We're asked to find the sum of the first 40 terms. So in this case, n is 40, and we don't know what the 40th term is. So instead, it's actually better to use the other formula because this includes things that we do know. We've got n over 2 times the quantity 2a plus n minus 1 times d. So in this case, n is 40. So we've got 40 over 2 times the quantity 2 times a. Well, a represents the first term, which is 3, plus n minus 1. If n is 40, then n minus 1 is 39, times d, the common difference. If we look at the terms that we have, we can see that the common difference is 4. 7 minus 3 is 4, 11 minus 7 is 4, etc. So that's going to be 39 times 4. So now we just need to evaluate this. 40 divided by 2 is 20. And then in the parentheses, we've got 6 plus 156. 6 plus 156 is 162. And 20 times 162 is 3,240. So the sum of those first 40 terms is 3,240, which we got much more simply than actually going ahead and writing out 40 terms and then trying to add all of them together. In situations like these, the formulas are generally much simpler. I want you to take a look at the example problems linked below, because we do have several problems that are application problems or word problems that involve situations where we have arithmetic sequences and partial sums.